All right, guys, this note set is on enzymes. Um, Need to know what an enzyme does, what the structure of it, not specifics, but like where's the active site. Need to be able to identify the different parts. So, for example, this picture, know that this is the enzyme, this is the active site, and this is the substrate. And we'll define all of these things in this note set. All right. A chemical reaction is a process by which atoms or molecules in a substance are reorganized into a different substance. All right. This requires energy. Chemical reactions allow living things to grow, develop, reproduce, and adapt. All right. The activation energy is the minimum amount of energy needed for the reactants to form products. All right. So this is a typical graph of an enzymatic reaction. We've got energy on this axis. We've got the reaction path on the x-axis. So here are reactants and here are products, but you have to put in this much energy. You have to get over this hill in order to get from reactants to products. All right, and this hill is known as the activation energy. So you would look at where the reactants are and the maximum point on that graph to figure the activation energy. A catalyst is a substance that lowers the activation energy that is needed to start a chemical reaction. Enzymes are biological catalysts. So there are other types of catalysts. They don't have to be biological, but the biological ones are called enzymes. All right. Enzymes are made of proteins, and the way they work is they speed up a reaction by lowering the activation energy. So think of, do you want to have to get to the top of Mount Everest, or do you just want to go over a small hill? All right. How many times can you get to the top of Mount Everest versus how many times you could get to the top of a small hill in the same amount of time? So that's what an enzyme does. It changes Mount Everest to a small hill so that you could do it faster and you could do it more frequently. A chemical reaction shows the reactants starting on the left side of the arrow, so sort of behind the arrow, and the products are shown on the right side of the arrow, so in front of the arrow. So if I give you a chemical reaction and say, hey guys, what are the reactants here and what are the products? You should be able to know based on where each atoms and molecules are in relation to the arrow. There are two types of reactions. Reactions can be endothermic, where they absorb heat, and the reactants are going to have less energy than the products. Or they can be exothermic, right, where they give off heat, right? So an endothermic reaction would feel cold to the touch, let's say if it were happening in a test tube, and an exothermic reaction would feel hot to the touch if it were happening in a test tube. Enzymes bind to reactants at this the reactant that binds to the enzyme is called the substrate, and the specific location where it binds is called the active site. So the substrate is a thing that's binding to the enzyme. The place where it binds is called the active site, and when they are bound together, it forms the enzyme substrate complex, and after the enzyme works on the substrate, it changes it to create a new product. So here's the thing. You are very likely, I can promise you that you will see a question like this. If not on the EOC, then certainly on one of my quizzes, where I will give you this diagram or something similar, and I will ask you to identify something, whether it's the enzyme, or the substrate, or the enzyme substrate complex, or the products. So need to be able to create your own, need to be able to imagine this diagram without the pictures, Some hints are the enzyme never changes. So you want to look at this picture and you want to see what is the thing that's not changing in this reaction, right? The substrate and the products obviously are going to change, right? So be able to identify this. Enzymes have many properties. One, they're made of proteins, right? They're folded into a particular three-dimensional shape. They're specific. Each type of enzyme will only fit one substrate. And this is known as a lock and key mechanism, right? Where the substrate is a key and the enzyme is a lock. And when they're together, again, they're the enzyme substrate complex. Enzymes make bonds to form one product, or they can break bonds to form two products. So it depends on what kind of enzyme it is. Is it an enzyme that is building something? For example, in this case, it is taking two substrates and it is joining them together to form one product. Or is it an enzyme that's breaking down something where it's taking one substrate and it is breaking bonds within it to form two products? Enzymes can be denatured. They can lose their specific shape, right? This can be caused by a change in temperature or pH. They can be renatured as well, but that doesn't always happen, right? So an enzyme usually has a three-dimensional shape, a tertiary structure, or maybe even a quaternary structure, and it's folded in a particular way. If you change the temperature or the pH, and this causes the protein to become unfolded, then it can no longer fit. The active site is no longer the same, so it can't fit with whatever substrate it is supposed to fit with. It is considered to be denatured. There are several ways to change the rate of a chemical reaction. The temperature is one. So temperature is a funky little thing. Increasing the temperature does help to increase the rate of reaction up to a certain point. Enzymes have what they call an optimal rate, right? And so if you pass this, the reaction is not going to increase anymore, but it's going to decrease because you run into the idea of denaturing the enzyme. You could change the pH. Most enzymes work at a specific pH, and changing the pH can affect the rate of the reaction. And again, enzymes work at a specific pH, and so if you change it, and it changes the active site, then it can no longer fit the substrate, and so it would slow down the reaction. You can change the substrate concentration. The higher the amounts of substrate, the faster the reaction will go, right? You could add a catalyst. So catalysts, like enzymes, are used to speed up a rate of a reaction. They don't have to be biological, so you can add a non-biological catalyst to a reaction. And you can add a competitive inhibitor, and that's something that occupies the active site and prevents the enzyme from binding to it. So a competitive inhibitor would slow down the rate of a reaction. You could add a coenzyme or a cofactor, and this is something that's added to help the enzyme work more efficiently. So here's a picture of that. So here's the enzyme in its inactive state. Once you add the coenzyme, what it does is it activates the enzyme by giving it the correct shape to fit its substrate. So now it could form an enzyme substrate complex, and it could actually do what it's supposed to do. Processes that use enzymes are, for example, when a person's bitten by a snake, the enzymes in the venom breaks down the membranes of that person's red blood cell to give that bruised appearance. I should have Google it, guys. It's a really gross picture. Or if you've ever been bitten by a snake, you might know what that looks like. Photosynthesis and respiration are processes that use enzymes, the ripening of fruits, the digesting of foods, and lots of other processes wouldn't be able to happen quick enough if you didn't have an enzyme to help it go. All right, that's it for enzymes. Copy your notes into your notebook and take a picture and upload it to the enzymes assignment.